Welcome viewers. In the last session we have discussed about the modes of 555 timer IC, and today we will be discussing on monostable multivibrators. In modern systems, multivibrators are widely used for processing and generating pulses. Mainly these are electronic circuits that are used to implement a kind of simple two-state systems like timers, oscillators and flip-flops. These circuits are identified by two amplifying devices, cross-coupled by resistor and capacitor. In our previous videos, we discussed that multivibrators are categorized into three types based on the number of stable states. Monostable multivibrator is commonly known as one-shot multivibrator, as its name indicates that it has one stable state and switches to an unstable state within a predetermined time when it is triggered. The time t can be determined by the RC time constant in the circuit. This mode of 555 timer is generally used for generating pulse width modulated waves. The figure represents the schematic of any 555 as a monostable multivibrator. We already know it is an operation mode of the IC any 555. It needs only two extra components to perform as a monostable multivibrator: a resistor and a capacitor. The parts of the connection are as follows. The pin 1 and 8 are connected to ground and the supply, which is VCC. The output is obtained from pin 3. To avoid any unintended reset of the circuit, pin 4 is connected to the VCC. The control voltage input, that is pin 5, should be grounded when not in use. It is connected to the ground via a small capacitor of capacitance 0.01 microfarad to the filter noise. Now coming to the working principle, to understand its working principle, let's focus on the inner structure of the IC along with the external components and connections. Initially, while the output is low, the circuit is in a stable state. The transistor is active and the capacitor is connected to the ground. When a negative pulse is connected to pin 2, the trigger input falls below positive 1/3 of VCC. The output of the comparator becomes high, that results the flip-flop, and consequently the transistor turns off and the output goes high. This is the change of output from stable to quasi-stable state, as we can see in the figure. As soon as the discharge transistor is cut off, the capacitor starts charging from positive VCC through resistance RA with a time constant that is equal to RAC. While charging, when the capacitor voltage becomes somewhat greater than 2/3 of VCC, the output of comparator 1 becomes high, which sets the flip-flop. At this time, transistor goes to saturation through discharging the capacitor C, and the output of the timer goes low. Like this, the output returns back to a stable state from quasi-stable state. The cycle repeats in this way. The waveforms of trigger input, output, and capacitor voltage are displayed. Now, pulse width derivation. We understand that the voltage across the capacitor C increases exponentially. Hence, we can write the equation for the capacitor voltage Vc as Vc is equal to VCC multiplied by 1 minus e to the power t by RAC. When the capacitor voltage is 2/3 of VCC, then 2/3 of VCC is equal to 1 minus e to the power t by RAC. And after further simplification, we get the value of t as 1.1 RAC. So the pulse width of the output rectangular pulse is T high is equal to 1.1 RC. Now the applications of monostable multivibrator. The device has several functions in the field of electronics. We will be discussing some of the applications. The first one is frequency divider. Through adjusting the time interval of T of the charging or the timing circuit, the method can be assigned to work as a frequency divider circuit. When the timing interval T is slightly larger than the time of the input pulse, the device can act as a divider by two circuits. The timing interval is controlled by properly choosing the values of the resistor R and the capacitor C. The waveforms of the input and output signals of the divide by two circuits are shown. Pulse width modulation. The monostable mode of action of the IC NE555 can be converted into a pulse width modulator by implementing a modulating signal in the control voltage input pin 5. The circuit of a pulse width modulator using a monostable multivibrator is shown. Now, linear ramp generator. With the addition of a current mirror consisting of a diode and a PNP transistor is used as a constant current source. This constant current source is placed in the timing resistor. The circuit for a linear ramp generator with IC555 in monostable mode is displayed. With this, we have come to an end of this lecture, and today we learned Introduction to monostable multivibrator, circuit diagram and connections of monostable multivibrator, working principle of monostable multivibrator, pulse width derivation, and applications of monostable multivibrator.